Hello boys and girls, and welcome to lesson 5-3, Complex Fractions and Unit Rates. This lesson is found on page 194. Today we will practice simplifying complex fractions and finding unit rates. So what is a complex fraction? Let's see if we can zoom this in a little more. There we go. These are fractions like 1/3 over half are called complex fractions. Complex fractions are fractions with one or more fractions in the numerator, denominator, or both. Complex fractions are simplified when both numerator and denominator are integers, so they become a whole number, either negative or positive. Now, this fraction can be rewritten as 1/3 divided by a half. And now it starts to look a little bit more simple, right? This one, when we write it as a division and we want to simplify it. From there we find the reciprocal. So it would be the same as writing 1/3 times 2 over 1. So all I've done is I've flipped the second fraction. And then we can go ahead and multiply. And we have 2 and then 3. So we have 2/3, which would be, now I've run out of room, 0.6 bar notation, right? So those are all the same. You can write this right here, this expression, like this or like this. But right here we've simplified it where it says when both numerator and denominator are integers. Well, right here the numerator and the denominator are integers. So that would be the simplest form to write it. I just went one step further to show you how you can convert it into a decimal as well, but this would be the way to write it. And you can see that they've done so in example 1. Okay, let's try 1A, B, and C. At this point you can pause the video and try these on your own. The first step is writing them all as division. As you see there, right there, and there. Now we want to find the reciprocal to each one. So we have to flip each second fraction. And I've also changed the division for multiplication sign. So the reciprocal, it's the flipped fraction and you multiply. Now you can go ahead and multiply it straight across. You can also check for cross-referencing, but I don't see any cross-referencing. Okay, you cannot cross-reference these, you cannot cross-reference those. So we just multiply straight across. So 4 times 1 or 1 times 4 is 4, 3 times 1 is 3. I have an improper fraction, so I have to change it to a mixed number. How many 3's are in 4? There's 1. And what do you have left over? You have 1 in the top left over 1/3. So it's 1 and 1/3, right? Next we have 8/9, okay, that is simplified already, and 7 over 30, or 7/30. For example 2, we have one of the numbers is a fraction, the numerator is a fraction, and the denominator is an integer. And we know that we can still write it as a division, and all integers, all whole numbers, are always over 1. But the reciprocal, so here this would be over 1, as so, right? But the reciprocal would be the opposite, the flipped version of that with the multiplication sign. And once you have that, you multiply straight across. 1 times 1 is 1, and 4 times 2 is 8, and you have 1/8. Okay, so 1/4 divided by 2, or 1/4 over 2, is equal to 1/8. So again, copy these down as division problems or division questions, and or numerical expression is really the word I should say, and then solve. So go ahead and pause the video. Okay, I've gone ahead and done so, and you can see that it's 2/3 divided by 7, 2/4, or really a half, divided by 2, and 14 divided by 7/9. Now here I was tempted to write 14 over 7 divided by 9, but please pay attention carefully to the lines. You see this line is bigger than this one, so this little line is part of this fraction, while this line is our division line. Okay, now I can go ahead and put all my integers over 1. Okay, now I want to cross-reference. Actually, no, I have to find the reciprocal, so let me write the reciprocal down. Okay, so I just went ahead, changed the division signs to multiplication, and I flipped the second fraction, as you can see. Okay, that is called the multiplicative inverse. Now I can go ahead and cross-reference. I can't cross-reference there. Cross-referencing means simplify. I can cross-reference here because I have multiples of 2. So what happens then is that I replace this with the 1, and there's a 1 there. Okay, and over here in the next one I can also cross-reference the 14 and the 7 because they're both multiples of 7. I have 2 7s there and I have 1 there. Okay, now I can multiply straight across. 2 times 1 is 2, and 3 times 7 is 21. 1 times 1 is 1, and 4 times 1 is 4, and 2 times 9 is 18, over 1, which is just 18. You see, it would be over 1. And there's your answers. Okay, another key concept for today is when the fractions of a complex fraction represents different units, you can find the unit rate. When they're saying, for example, 60 kilometers for every 2 hours, that means you can drive 30 kilometers in 1 hour. Okay, and so on. Those are different units. You can find the unit rate. Let's look at example 3. Josiah can jog 1 1/3 miles in a quarter of an hour. Find his average speed in miles per hour. So what we're going to do is we're going to take our number of miles and we're going to divide it by the hour so that we can find the miles per hour. And you can see here that it's written as a complex fraction, then as a division, and then we change or convert or rename the mixed number into an improper fraction. Then we find the reciprocal. We go ahead and multiply across. We get 16 and 1. And then we change the improper fraction back to a mixed number. How many 3's are in 16? There's 5 of them, right? And there's 1 left over, 1 remainder over 3. And so that means that Josiah, I would say this, or Josiah jogs at an average speed of 5 1/3 miles per hour. Okay, I think we're ready to try some word problem. A truck driver drove 350 miles, okay, 350 miles in 8 3/4 hours. 8 3/4 hours. What is the speed of the truck in miles per hour? Okay, so I went ahead and wrote our complex fraction into a division problem by also putting the 350 over 1. Now I'm going to look for the multiplicative inverse, which is 350 over 1 times 4 over 35. And now, because it's a multiplication problem, I can cross-reference. And I see here that I have 350 and here 35. So clearly, there's 135 here and there's 10 of them there. So I can go ahead and cross this out. I put 1 there and 10 there. So 10 times 4 equals 40. And there's our answer. You can travel 40 miles per hour. 40 miles per hour. Okay, Aubrey can walk 4.5 miles in 1.5 hours. Find her average speed in miles. So again, let's write it down as a division problem. And this is what we get. Now we can go ahead and convert these mixed numbers into improper fractions. Okay, now let's look for the reciprocal. So the reciprocal, 9 over 2, would be times 2 over 3. Just flip the second one, remember. Now we can cross-reference. And I see multiples of 2's and multiples of 3. So we want to cross-reference, and we have 1 there and 1 there, multiples of 2, and then multiples of 3, I have 1 3 there and 3 3 there. And when I finally multiply straight through, I'm going to have 3 times 1 is 3, and 1 times 1 is 1. We could write it, but there's no need to write an integer over 1, because it still ends up being 3. 3 divided by 1 is 3. And there's our answer, 3 miles per hour. And another concept right here. You can also use complex fractions to write some percents as fractions. So we can write some percents as fractions. Let's see an example. You see here that we have 33 1/3% as a fraction. Okay, this is 33 bar notation. When we write it out of a percent, okay, we can write it out of 100 to make it out of per 100%. Okay, so it's being divided by 100, and when we do so, you'll see that we're going to get 1/3, because 33.3% is actually 1/3 of 100. Okay, let's try to write A as we did in the example, 4.5 over 100. Now let's write it as a division problem. Okay, and you know that it's 100 over 1. And then let's find the reciprocal. There it is. We flip the second one. And now I'm going to continue up here with by converting this mixed number into an improper fraction. And 4 times 2 is 8, plus 1 is 9 over 2 times 1 over 100. And now I can just go ahead and multiply straight through because there's no cross-referencing, and I have 9 over 200. And there it is. Okay? That's our answer for number 1. Okay, let's do the same with 12.5 divided by 100. And remember that it's 100 over 1, right? And then let's change the mixed number into an improper fraction. So 2 times 12 is 24, plus 1 is 25 over, oops, not 25 over 1, it's 25 over 2. Little mistake I made there. We'll change that to 2. And then we found the reciprocal, which is 1 over 100. We can cross-reference. We have 25. We have multiples of 25. I have 1 there and I have 4 there. And then when I multiply straight through, I have 1 times 1 is 1. And 2 times 4 is 8. So that's 1/8. So 12.5 is 1/8. And you guys already knew that because we practiced that in class, counting by eighths. Okay, now we have 10 2/3 divided by 100, divide 100 over 1, and now I converted the mixed number into an improper fraction and found the reciprocal, and I can cross-reference. And I see here that I have even numbers where I can cut this down to 16 and this down to 50, and I can do it again down to 8 and again down to 25, right? So now I have 8 times 1 equals 8. And 3 times 25 equals 75. And there's my answer. I'm going to go right there. And finally, 3.5%. 3.5 divided by 100. Put the 100 over 1. And it's 10 over 3. Because 3 times 3 is 9. Plus 1 is 10. Times 1 over 100. We cross-reference. And now I have multiples of 10. I have 1 there. And I have 10 here. And I multiply. 1 times 1 equals 1. And 3 times 10 equals 30. So it's 1/30. And there we go. That's my answer for that. And I just want you to make sense of it all. What we're saying is 3 and 1/3, is 1/30 of 100. That's what this is. This is 1/30 of 100. Literally, we've taken this number, okay, and we simplified it to become this. That's all we've really done. And I want you to make sense of that. Okay? Well, that's all for today, boys and girls. We'll do the guided practice in class and the independent practice. I'll see you then.